Welcome back. In this lesson, moving forward, I'm going to talk about everything that you need to know about an IP address. So whenever two computers talk to each other or two devices communicate, each device has to have a certain address, just like we have addresses of our homes, and we have streets, they have names, numbers, and so on. And each house is unique. No two houses have the same address. That's how you get your mail delivered through a postman, for example. Similar concept applies to a network. So each computer on the network has to have a unique address so that information can be shared and data can be sent. And this is called the IP address. So it looks like a bunch of numbers such as 10.0.2.15. The first three octets, or the first three numbers, so to speak, are the street address, and then of course the last one is your actual house number. So think of an IP address as just an address that is unique to each computer on the network. So the Internet Protocol address is a unique address, as I mentioned earlier, that computing devices such as computers, tablets, smartphones, they use to identify themselves and communicate with other devices within the network. So any devices connected to the IP network must have a unique address. Otherwise, there will be a conflict of an IP address. Two different types of IP addresses. One is broadly the private or the public IP address. So the IP address can be private for use on a local area network, or public if you like to use it on the internet or other wide area network. IP addresses can be determined statically. In other words, you can log on to a computer, laptop, device and physically specify an IP address for that computer, or dynamically assigned by another device on the network on demand. So for example, if your computer does not have a unique IP address, soon as you turn your computer on, the server on your network, the central server, the repository, right, the storage, will give you an IP address as soon as you turn your computer on. So either it can be static, in other words, a permanent IP address for that computer, or it could be dynamic. And we'll take a look at what DHCP, or dynamic allocation of IP addresses, is a little later, but just for now, understand that they can be determined either statically or dynamically. So here's an example. An IP address is formatted as just a series of 4 values separated by periods. So 192.168.0.1. So you're probably thinking, how am I going to know what these numbers are? Which numbers can I use? So each value can range from 0 through 255. The IP address assigned to your personal computer or your laptop on a network is called a local address. So the local IP address can start with 192.168 and it can start with 10.0 and so on. The TCP IP, which basically is an acronym for Transmission Control Protocol, Internet Protocol. So the IP is often prefixed by the acronym TCP. The TCP part stands for Transfer Control Protocol. It's simply a set of rules for transmitting information on a network. So technically speaking, in the IT world, TCP IP refers to the methods and engineering as opposed to a specific address or value. So it doesn't relate or talks about a specific value, but it's actually a method. Next, I'm going to talk about the IP classes. So the internet community originally defined 5 address classes to accommodate networks of varying sizes. So for example, if you're living in a certain subdivision, for example, it's a small subdivision, you are going to have your own bunch of numbers that you can pick and choose your own addresses. If you're talking about a city itself and you like to provide IP addresses for each of the houses in the entire city area, you may have to allocate a range of IP addresses specifically to that city. So Microsoft TCP/IP basically supports Class A, B, and C addresses assigned to various computers or hosts. The class of address that defines which bits are used for the network ID and which bits are used for the host ID. It also defines the possible number of networks and the number of hosts per network. So now we're talking about bits where each unique IP address is being assigned to a certain host or a computer on the network. So let's talk about Class A. Of course, there are three classes, right? Class A, B, and C. So let's elaborate upon the Class A addresses, which are typically assigned to networks with a large number of hosts. So that's the key word, large number of computers. The high order bit in a Class A address is always set to 0. The next 7 bits completing the first octet complete the network ID. And the remaining 24 bits, which are the last 3 octets, represent the host ID. So essentially, this would allow for about 126 networks and about 16,777,214 hosts per network. So you'll notice that the first part is your network ID, and then of course your host ID as part of the Class A network. Then we have the Class B addresses, which are assigned to medium size to large size networks. The 2 high order bits in the Class B address are always set to binary 1 and 0. The next 14 bits completing the first 2 octets complete the network ID itself, and the remaining 16 bits represent the host ID. So for a Class B address, you can have about 16,384 networks with 65,534 hosts per network. So again, Class A just took the first part of the network ID, and then Class B had both of them, binary 1 and 0. And then we have the Class C, which is used for small networks. The 3 high order bits in a Class C are always set to binary 1, 1, 0. The next 21 bits complete the network ID. So you can see a pattern here, right, from A, B, and C. And of course, the remaining 8 bits represent the actual host ID. And this allows for about 2 million networks and 254 hosts per network. So once again, just remember the Class A, Class B, and Class C IP addresses. Here's the summary of what we just talked about. So we have Class A, B, and C, and the grid provides the values for the network ID portion, the host ID, the available networks, and the hosts per network that you can have within the Class A, B, and C IP addresses respectively. So just go over some of these basic concepts. These are important because you will come across this almost all the time. So I hope this helps. Practice, and let's move to the next lesson.